Two-sample t-test. We've done two-sample t-interval. The difference is that we don't know the sigma, we don't know the population standard deviation, so we have to use SI, which in real life is probably more popular. H null, does mu1 equal mu2, where mu1 and mu2 are equal to what? Okay, just make sure you talk about your parameter. Your alternative, mu1 is less than, greater than, or not equal to. Still one-sided or two-sided, that doesn't change. Name the test, because we have a million tests now, so we got to name the two-sample t-test. The assumptions, simple random sample. Is it normal? Both sets of data have to be approximately normal. Test N1 and N2, are they both greater than or equal to 30? If they're not, then we have to follow this rule. Sample size less than 15. This is nothing new, so you don't need to write this down. If your sample size is less than 15, they have to be close to normal or roughly symmetric. No outliers and no skewness. Nothing new there. Sample size has to be, if it's between 15 and 30, basically. Two-sample procedures can be used except in the presence of outliers or strong skewness. Nothing new there. And large sample is a two-sample if it's greater than or equal to 30, even for clearly skewed distributions when both samples or groups are large enough. Nothing new there. Difference here is that we have two sets. So if one of the two is not working or is not more than the 30, then we have to test it with a histogram or a box and whiskers or something like that, right? Then the other note I wanted to bring up was this. Remember, we always use the pooled sample proportion. Remember for sample proportion, when do you pool? When do they use that word pool? When we did a two-sample proportion.
The standard deviations of the study?
Not for proportion, because we don't have standard deviations for proportions. It's when you find the p combined. Remember you had the p little c, and when you go through combined, that's called pooled. That's the only time you will pool. All right. When performing a significance test for comparing the two proportions, we do not recommend pooling when comparing two means. So from here on out, don't ever pool. Your calculator will ask, just leave it as no. Pooled, question mark, just say no. Okay? We won't. They don't even recommend it in the book. So don't worry about it. Just always say no. The only time you do pool is when you're doing a proportion, but they never ask you that when they're doing the proportion. It's just something you have to do anyways. You have to combine it. Okay? All right. Independence replacement, bless you, for both samples is 10n less than the population is 10n2 less than the population. That hasn't changed. Degrees of freedom, smaller of the two, -1. That's the same as the two-sample t interval. Pooled, never. You can just say that. Here's your equation. x1 minus x2. I need to find the difference, just like I was doing a two-sample proportion. Divided by, wow, doesn't that look familiar? This right here? Same as this two-sample t interval, right? It's just your standard error. x1 minus x2 over the variance of the first over its sample size plus the variance of the second over its sample size. Conclusion doesn't change. At alpha 0.05, we reject the null, or you fail to reject the null in favor of, and then you talk about in context of the problem. This equation is really x1 minus x2 minus mu1 minus mu2. But just like a proportion, remember it was p1 minus p2, but we got to ignore it. Why do we ignore this mu1 and this mu2? Well, we have it. It's just that they're equal, right? And if they're equal, they're going to cancel each other out. So we just don't even put it into the equation. So this is your t-test. Now again, your standard deviation is right here. That's for an interval. Standard deviation for a test is the same thing. Instead of sigma, though, in this case, we got to use S. So it's on your College Board sheet, that standard error part, so you don't have to memorize it. You just have to realize I'm looking for the difference between the two. How will you know? Because you have two sets of data. That's probably one of the easier. And you're not dealing with a proportion. We good? All right, let's talk about males versus females. We took a sample yesterday. It's over there on the sideboard. I want you to take a good look at that. We've already taken the numbers, put them into the calculator last hour, but look, we had to cross them all out. Look at the difference between male and female. Females, are we a little, what would we say, left brain?
Orderly.
And males, we are right brain and scattered. We are a scattered learner. Way to prove it. There's got to be something psychologically going on right there. I don't know what it is, but it is just kind of just interesting. Females nice and orderly, nice and neat. And then go over to males, and we're like, is that a 35? What, you know, you got numbers all over. Is that supposed to be a 2? Then somebody decided they just wanted to draw a star. I just got either way, now that I got my data, here's our data. We found the mean. The mean is 4.14. Somebody write this down, because I'm going to flip to the next page, and I'm not going to have this. The mean is 4.14. The standard deviation is 1.83, and my sample size for males was 43. Female 7.32, 4.15, and my sample size is 25. Now that is what, a total of 68, and I have about 90 students in AP Stats. So we have 22 that did not participate. Bummer is, look at our female sample. How big is our female sample? Not enough, so we're going to have to do a test. We're going to have to do that extra mile. So thank you for making it a good experience, a good sample to go through. We got this written down, so I can go on to the next one. So let's fill this in, and you can just sit back and watch. Probably, if you want to take a note on it, you can. This is being recorded, so it'll be on the internet again, so you can scroll through if you just go, I wasn't sure. It'll be on YouTube. All right, two sample t-tests. Mu1 is equal to mu2, where mu1 is the number of genes on average female students have in Mr. Flourish's class, and mu2 is the average number for the males. I need to cross this something out, and I did this on purpose. The number of genes on average female students have in Mr. Flo's class. Why do I have to cross that out? Am I interested? What's my parameter? What's the population I'm looking at?
The genes people own.
Teenagers, maybe. You know, how many teenagers, males versus females? How many genes teenagers, male versus females, own? Right? That's what I'm interested in, not just my class. Otherwise, I'm gonna not make that. You know, it's the population thing. 10n is not going to work. It's not going to be less than the population. So my parameter has to be expanded. So realize when you talk about your mu1 and mu2, you're talking about in terms of the parameter. Don't talk about in our sample. No, then it would be x1 and x2. Okay? I want to know do females own more genes than males? Why did I do that? Because females had more on the average, right? So that's why I'm making it one-sided. And if I wanted to, I could change this to females and males, mu f greater than mu m. And follow through with that if we wanted to. Two sample t-test, because we have two sets of data, two separate groups, and we can only get the standard deviation from my sample. Simple random sample, we'll assume yes. Normal, both sets of data have to be approximately normal. Test both. Males, we were, what was there, 43? 43. So 43 is greater than or equal to 30, so we're good there. Females, 25 is not greater than or equal to 30. So we have to test. Okay? And you type these into your calculator and do what? You would have already, but what do I have to do since it's not greater than or equal to 30? You have to graph it. Okay? And when you graph it, you get a histogram that looks like this. Space, and then space, and then space. So we actually had skewness, and we have outliers. If you did a modified box and whiskers, which is the fourth graph, it will point out 2 outliers in this scenario. Okay, I'm guessing 21 and, oh, so there must be 3 outliers because there's 2 15s, right? Those are our outliers. Thank you, period 6. Okay, so what does this mean then? I'm not going to just stop here. If in real life, I'd have to go ask a few more females. So I'm just going to proceed with caution so we can continue to walk through the problem. So proceed with caution. Independence, replacement for both samples is 10 times 43 again, less than the population of teenagers that own genes. I don't think we have to worry about that. And is 10 times 25 less than the population of females that own genes? The number of females that own genes? Yeah, no problem there. Degrees of freedom. What's my degrees of freedom? Because we're doing a T. 24. 25, the smaller of the two, minus 1, which is 24. Pooled? No. Okay. Then we set it up. Just fill it in. X1 minus X2. We're doing females compared to males, right? So I'm going to I'm doing females greater than males, so then these numbers have to match up here. Keep that in mind, all right? I see that a lot where people flip these and they're not quite sure. You've already set it up. If you're saying this is greater than this, then this goes here and this goes there. You should go in that same order so that you don't make the mistake at the end. All right, X1, what was our female?
7.32.
Okay, males?
4.14.
Thank you. Divided by square root of the standard deviation for females. So that was a huge standard deviation. I got to square that. Divided by the 25 plus males. So that one was a smaller one. So it looks like females have a larger count than males, but they have a larger standard deviation. But does that matter? In the end, and there were what, 43 males, right? Now go to your calculator. Stat tests. 2-sample t-test. Thank you, calculator. What is it, C? So scroll up.
No, I was saying Espanol C.
Oh, gotcha. I think you're still scrolling up probably fast. But either ways, go to 2-sample T.
It's like 3 or 4. You just go down.
Oh, it's right away?
Yeah, it's
oh,
right there.
so now then stay there. So number 4. Anyways, type it in. Your X1 is 7.32. Sample size, or your standard deviation, 4.15. Don't put the variance in. It'll do that for you. So make sure you know how to do that. All right, who's got my t-value?
It's 3.63.
Second on that?
Yep.
Double check, make sure you're getting that for people that are following along. And what's my p-value then?
Approximately 0.
Ooh, I like how he even said approximately 0. What are you going to get? 5.1 something times 10 to the... Okay, if you put 5.2 on the test, you need to slap yourself. Okay? Yeah. Can you ever get a probability over 1? No. So that's where you go, ooh, something's going on. Oh, this is times 10 to the, and then look and go. It's probably 0. So my probability is about 0. Conclusion, at alpha 0.05, what are we going to do? Reject the null. In favor of what? Women have more genes than males on average. Right? Okay, doesn't surprise me. Take out that 21 and those two 15s, and I bet we're pretty comparable. I bet we would find that we're not. That's why we have such big standard deviations, because of those bigger numbers. Okay, let's say I ask you, describe this in the context of the problem. Describe this in terms of your p-value. You had a question like this on the last test, remember, and it was You came up with, you did the full test, and then you made your conclusion, and then I said, now talk about it in the context of your p-value. How would you say this? Anybody want to take a guess? In the context of the p-value, what does this mean? What did you find? Because what happens is you can go through this, people have this memorized, and they go, yeah, this is so easy. But then all of a sudden they ask that type of question. In other words, do you really know what you have found? Joe, you give it a shot? I love it. Go for it.
I think it's like if you're assuming that males and females own the same amount of genes, then the probability that we would get what we got was like 0.
Bada boom. Nicely done. Assuming that they're the same, men and females have the same amount of genes, the probability that we would get a difference as much as we did, 7.32 minus 4.14, will happen approximately 0% of the time. Should it happen? If they really are the same? No, that's what you're finding. Did it happen?
Yeah.
You can observe, yeah, it happened. So then we'd say, oh, then I'd say they're probably not the same because it shouldn't happen, and it did. We found evidence that there's a difference. The only difference is what? I might add something to this, and that is what? But one of our rules didn't hold true, so I still have some reservations about it or something like that. It's the only thing I would maybe add to that. One more thing. Let's say we go through the whole thing, our t-value, and I don't give you the numbers, all right? And all I say, and they like to have questions like this on the AP, all I say is your t-value is 3.63. What would be your probability? Okay? Your t-value is 3.63, and what's your probability? And that's it. You can type it into your calculator because you don't know the other information. That's all I've given you except for the sample sizes. So you go to your table. They're going to test sometimes to make sure you just understand the table straight out. Easy question if you know how to do the table. This is one where you'd be like, sweet, I got this one. How do you find your value? What's the degrees of freedom? What row do we look at? 24, right? 25 minus 1, so our degrees of freedom is 24. So I'm looking at that row. And how do I find my probability? If I can't use my calculator. Okay, our t-value was 3.63, I think.
3.63.
Where does 3.63 fall?
In
Between those two, right? So I would say that my probability is between 0.0005 and 0.001. I don't know exactly, but I can tell you it's somewhere. Either way, I'm still going to reject the null. It's so low, right? What if I said it was a not equal to? Because this was a greater than. What if I said it was a not equal to? What do you have to do? What changes in my probability? I hear people whispering, but I don't know what you're saying. Somebody have some confidence. Tell me. Gusto. Thank you. Multiply by 2. Multiply both of those sides by 2, so we're really talking about a probability, just write this here, that is less than 0.001, greater than 0.0005 if it's a one-sided. If it's two-sided, I need to multiply by 2, so it just becomes p is less than 0.002, but greater than 0.001. That's the only difference. And I really wouldn't be surprised. Remember, most of the tests, you don't even use your calculator because they can still ask you questions like this. They've done all the work for you, and they're just saying, what would be my probability? They're testing you real quick. Do you understand what it even means? Questions? That's all I've got for you.